Hello, class. This is Miss Dallard, and I'm going to try to teach you guys a little bit about energy. So you guys should already have pulled up your notes. You can type in the missing pieces. We'll go through these notes and try to see. Hopefully, you guys won't have too many questions. So the first thing here is about energy. You should realize that energy is the ability to change or move matter. For the SI unit for energy, you guys know that we use the metric system. So for energy, it's going to be joules, and that will be a capital J. There are two major types of energy that we're going to focus on. One is potential energy, and the other is kinetic energy. If at any point in time, guys, I'm going too fast, just stop the video, type in what you need, and we can move on after that. So potential energy. Potential energy is the first one that I want to talk to you guys about. Potential energy is the energy of an object due to its position. When we talk about position in this class, we're talking about the position above the ground. So anything that is above the ground will have potential energy. When you think of potential energy, you should think of potential energy in the terms of something that has the potential to fall. The equation here is PE is equal to M times G times H. PE obviously stands for potential energy. M, you guys should remember, stands for mass. G stands for gravity. And H stands for the height. Remember, we're talking about something above the ground, so there's where the H comes into play. Kinetic energy. Kinetic energy is the energy of an object due to its motion. Here is our equation for kinetic energy. Kinetic energy is 1/2 times the mass times velocity squared. Note that I have here that only the velocity is squared. Sometimes you guys try to square the final answer, and it's just the velocity. Anything that is moving will have some type of kinetic energy. So if there's no motion, then there's no kinetic energy. Energy on a large scale is called mechanical energy. Mechanical energy is the sum of potential and kinetic energy in a large scale system. We're not talking about those tiny atoms and molecules that we learned about at the beginning of the year in chemistry. Energy on a microscopic scale is called non-mechanical energy. That's the energy that we're talking about when we're talking about those atoms and molecules and those electrons moving around. They can still be considered kinetic or potential because anytime there's some kind of motion, then we can call that energy. There are specific types of non-mechanical energy, and we can classify these as being potential or kinetic. So chemical energy would be like the energy that you store in your muscles. So you guys know that as you have that ability to move, we do call that ATP. You'll talk about that more in biology, but that is a form of potential energy. We also have thermal energy, which many times we just call heat energy. So I'm okay with you calling it heat energy. And it could be due to friction. You guys know that when two objects oppose the motion, you've got some type of friction. So that is your heat energy. That is movement. And so therefore that's kinetic energy. We also have sound energy, which we'll talk about later on in the year a good bit, but sound energy is due to vibration. So hopefully you guys recognize the fact that if it's vibrating, then that would also be kinetic energy. We also have radiant energy. Radiant energy, we typically say light, so I'm okay with you guys saying light energy, but light does travel as a wave. That's another thing we'll talk about with sound. And light energy, since it's moving as a wave, therefore it would be kinetic type of energy. We have electrical energy. The electrical energy is due to the flow of electrons. So with electrical energy, since we're talking about the flow of electrons, that's movement again. So that too would be kinetic energy. The last one here is spring energy. When you think about spring energy, you have to think about it like a compressed spring. So it's actually a mechanical type of energy because we can actually see that type of energy. But with a spring energy, if something is compressed, you should think about it in terms of potential energy because it does have that potential to move. And that's where I want to stop our video for now. We'll pick back up with the conservation of energy at a later date.